So in this example, I saw a lot of people do a lot of great things from this one. What it's saying is there's some kind of chain, right, that's being pulled at 125 newtons, and then one that was at 300 newtons. Correct? Now, so if that's 125, 300 should look like this. Now, based off of what we've talked about, adding and subtracting vectors, right, you can see I represented the force by their magnitude and gave you different directions, right? If we were going to add them doing our head to tail method, we would probably have something. Oh, and this is at 45 degrees. Right? If I did head to tail method, I could probably assume that my resultant vector is going to be somewhere over here, right? And can you guys also now assume that your angle of this resultant vector that we're going to find is less than 45 degrees? Does that make sense? So we're going to look for a vector that's going to be larger than both of these vectors and also at a smaller degree. All right? So the case is, how do we go ahead and find that? Well, the main important thing is when we have these vectors, remember, now we're not given exactly the coordinates. The only thing that we're given is the angle and its force and its magnitude. So what I can do is I can write both of these. I think, was this one u and this v? Either way, we're going to call them u and v. So anyways, what I'm going to do is I'm going to represent u. If I'm going to rep it in terms of a unit vector, I'm going to say this is cosine of 45 degrees I plus sine of 45 degrees j. Right? That isn't reflected as a unit vector. But we know it's not a unit vector because it has 125 Newton force applied to it. So I'm going to multiply that to represent that as my magnitude in this vector. Then I have v, which here you can see this angle. That angle's at 0. So in this case, I have 300 times cosine of 0 degrees plus 300 times sine of 30 degrees, or of 0 degrees. All right? Now, what's nice about 0 is sine of 0 is 0. 0 times 300 is 0. Cosine of 0 degrees is 1. 1 times 300 is 1. So we can say that v, I'll write it in component form now, is 300, 0. Right? That one was pretty simple. However, this one, I'm going to write it broken down using decimals, just so you guys can follow along with me, making sure that you have everything correct. But you can also keep it as an exact answer, and then just simplify it at the end. But for right now, if I do 125 times cosine of 45 degrees, my vector ends up being 88.38834765. Again, I'm just not going to approximate these. And then obviously 125 times sine. Well, sine and cosine, remember 45 degrees, sine and cosine are the same number, right? Right? Sine and cosine are the same at 45 degrees. Square root of 2 over 2, square root of 2 over 2. So this answer is going to be the exact same. OK? So now what they're asking, guys, is what is this resultant vector? Well, if this is u and that's v, this is u plus v. Right? So to find u plus v, I'm going to have to add these up, correct? Well, 88 and all this plus that is going to be 388.8834765, comma, this plus 0 is just now going to be 88.88 point, or 88.388. Now, again, as I mentioned, you can leave this as an exact answer and then use your decimals at the end. I'm just writing it in the decimals so you guys can see that when I do this in a calculator, I'm not going to approximate anything. That's why I'm just giving you guys full answers. So, but what was the question actually asking us? It says find the magnitude of this new vector, right? It says find the magnitude of the new vector as well as the direction. Well, let's go ahead and find the direction first. If let's call u plus w or U plus V. Let's call this now W, just to make things simple. OK? So I'm just going to call this W. The reason why is because I want to write this as W1 and W2. All right? So remember, if I wanted to find what is, so now this endpoint is W1, comma, W2. We now know the values. And now that we know the values of our terminal point, is it possible for us to find the angle? Yes. The angle is tangent of theta equals W2 over W1. Right? So now theta equals tan inverse of W2 over W1. So now I simply just do 88.3888 divided by 388.38834,765. And I get theta equals tan inverse of 0.2275 dot, 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 dot. I'm going to use the whole answer. I take the inverse tangent of that answer, and I get 12. Theta equals 12.82 degrees. So that's the angle. And does that kind of make some sense? Would that work for our problem? Yeah, it does work. Now we need to find the magnitude. What actually is the length? We know the magnitude here is 125 newtons of force. Here, the magnitude is 300 newtons of force. We know this new magnitude is going to be larger than both of those. But what exactly is it? Well, remember, to find magnitude, if we are going to use magnitude of W, which is really the sum of these two vectors, that equals the square root of W1 squared plus W2 squared. All right? So JJ, what I'm going to do now is I'm going to take these two vectors, square them, add them up, and then take the square root. So we'll do this right before class ends. 0.38834,765 squared plus 88.38834,765 squared. So that gives me the square root of 1,558,658.0086. Take the square root of that answer, and I get 398.32. So what that's saying is this distance is 398.32 newtons of force. And does that make sense? Does that kind of work with our word problem? Would it make sense? Yes? Yes? No? Yes, it does. It does. Yes? Huh?